Hello, there we go. Welcome back, Build Stuff. So joining us remotely, we have Dan North, who is inimitable, I suppose, very, very famous, and he's going to talk to us remotely from his sunny study about architecture and building new projects. So welcome, Dan, take it away.
Fantastic. Good afternoon, Vilnius. I'm hoping you can hear me. It's very strange sitting in a box, speaking to people thousands of kilometers away. So the theme for this conference is about the future. And from where I'm sitting, you folks are 2 hours in the future. So I'm hoping things are a lot better there. I'm hoping Twitter is no longer a dumpster fire, and that you have flying cars, because that would be very cool. That notwithstanding, I want to talk to you about when I talk to other people about the future. So what does that look like? That looks like, I've been working with a really interesting organization in India for the last few years. There were 5,000 people when I got there in 2018. They're now 10,000 people and growing fast. So, and they started out as a telco, 4G telco. And now they've kind of become a digital platform business. So that the telco is like a connectivity platform, if you like. And on top of that, they've built all kinds of interesting businesses. They've got entertainment, so TV and movies and sport and music. And then they have things like retail, health, education, finance. So lots of, you imagine all these different businesses. It's like a big set of largely independent businesses, but all on a shared platform. And one of the things they're really keen on is kind of connecting people up. I mean, in a big organization like that, it's really easy to get lost. And so some of the work I've been doing with them is setting up communities of practice, so getting people connected across the organization. And they have an architecture community, and the architecture community, as you can imagine, connects up architects across this now 10,000 person organization. And this talk came out of a question they asked probably about a year ago. And they said, look, we often get to start new things. And the problem with a large organization when you start new things is we end up with lots and lots of disconnected pieces. So what advice would you give me as an architect, as a technical lead, on a new piece of work? If I'm going in to build this new thing, what would that look like? And I thought that was a fascinating question. So I built a talk around it, and I've evolved that. And this is what I want to share with you today. I will try and keep space for questions at the end. I do not know how questions are going to work. So I'm going to keep my Zoom chat open. And I hope that if there are questions, some of the magical stuff pieces will ensure that they appear here. So let me start then. Start as you mean to go on. So what I asked these folks is this. I said, when you start a new project, when you start a new piece of work, what do you think about? And they said, we think about things like this. We think about which OS should we build on or deploy to, or cloud provider, or infrastructure platform like a Kubernetes or something like that. What should we build on? And then they ask questions like, what database or what kind of data store are we going to use? They ask questions like, what programming languages are we going to use? And again, when you bring in a program language, what you're bringing in is a whole tool chain, a whole separate path to live. So we need to think about effectively the ecology of these languages. So what technologies, what stack are we going to use to build this new thing? What's our big picture architecture? Are we looking at lots of small components? Are we looking at one big monolithic thing? Are we a headless service? Do we have a UI? What's our big picture? What's the thing that we're building into? And these are the kind of questions they said they noodle on. And sometimes they can noodle on them for a long time. Sometimes they don't noodle on them for very long at all. So we said, okay, well, let's take a look. Let's take a look at what happens, right? So we start off with really good intentions and some really good, we've thought about these things. And then what happens to software? Generally, when you have, especially when you have teams of teams, when you have lots of people working on something, they're all pushing towards some kind of definition of on time, on budget out there in the world somewhere, typically several pay grades above anyone doing the work. Someone's got a schedule, right? And the problem with on time and on budget is it can have some interesting consequences. So this is a story about Citibank. This was beginning of last year, I think. They, I don't know if any of you recognize this screen. You will never have seen this product unless you work in Citibank, and you will never have seen this screen unless you work in Citibank in settlements, right? In where they pay money from. This screen is how you pay stuff. And what Citibank was doing is they wanted to move some money internally. What they actually wanted to do was pay interest on a bunch of loans. And the way you pay interest on a bunch of loans is you move money to an internal account. And then the act of moving money kicks off a load of business rules, and then all the interest payments go out. So if you move money from yourself to yourself, then all that happens is the side effect of all the interest payments. And that was the plan. Now, in order for this to happen, you use this tool called FlexCube. And FlexCube, you can tell it's an internal application because it is ugly as sin, right? And the UX on this is just eye-watering. Anyway, so in order to move large sums of money around, and I mean large sums of money, in this case, billions of dollars, you need at least 3 levels of sign-off. So you need the person entering the value on the screen, and they enter the account code, the GL, General Ledger Code, for the principal, which is the payee, the person who's going to get the money. And then someone else, their supervisor, looks at that, and then a third person looks at that too. And they all looked at this code and they said, yep, that code is definitely an internal code. It's in the principal field, fantastic, go. When they pressed go, they accidentally put out 500 million. I think it might be 500. I've got on there 500 billion. I will need to check this. If it is, that's even worse. Pretty sure it's 500 million. Basically an eye-watering amount of money. Because what happened is this UI, it turns out, you don't just put the GL code in the principal field. If you want to do an internal trade, you also put it in the completely unobvious named front field and fund field, which you'll see a couple of spots up. Someone designed this, right? Someone else tested this. Someone thought this was a great idea for a product to look like. And then they even had the business processes to make sure that you couldn't possibly do the thing that they then did. The great part of this is that at the time when they did this, they had upset a lot of their creditors, right? And so when all this money went out, they then said, look, we've just made this really stupid mistake. Can you send it all back? And no one did, or most of them didn't. And they took it to court and they lost. So why am I telling you this? This is what happens when a bunch of people do things and they don't get to think about the consequences. So there's 2 ways that people don't get to think about the consequences. The first is when you have too little guidance, right? So what happens if, as a technical person building a new product, particularly in a large organization like a bank or a big telco, what happens if you have too little guidance? Well, everyone tries to help is what happens. They all do their very best. We've got experienced tech leads, experienced architects. They've been around the block. We've hired some people with great experience, and they have good ideas. And the thing is, all of those good ideas are different, because I've worked in different places from you, and we've worked in different places from her. And all of our tech leads and technical architect folks, they all come up with different solutions to the same problem. And all those solutions are fine, right? They're all fine. They're just all different from each other. And they end up in the same code base. And the great thing is they don't even know, right? They're all busy doing work, looking down their own, staying in their own lane. They've got no idea that elsewhere in the code base, we have this fragmentation going on. What does that mean? That means it's really hard to reason across modules within the same code base. It's certainly hard to reason across service boundaries. It's like each time you look at a different part of the code base, you may as well be joining a different company, right? There's no consistency. What does that mean? It means that second order things like debugging, diagnosing, supporting, all of that downstream stuff becomes really hard. Telemetry, figuring out what's going on, right, is inconsistent. The melt group, metrics, events, logs, traces, the information that lets you know what's going on in the system is inconsistent even within the same subsystems. And that's really, really hard to do anything useful with. We have this lovely idea called observability. Observability from control theory, the technical definition is this: whether we can infer internal state entirely from external outputs. In other words, by looking at what something's doing, can we figure out what's going on inside? If we're getting some strange readings, can that tell us what's going on? And the problem with observability is if you don't design it in from the get-go, it's practically impossible to kind of shove it in, shoehorn it in later. So that's our too little guidance. And then what if we've got too much guidance? Well, I suspect a lot of you are going to recognize this, right? This is where we then get big upfront design, big upfront architecture. And I see this in large organizations, I mean, literally down to sequence diagrams or pseudocode, right? So you're practically doing the work for the people, and then you're saying, go code this. And what does that lead to? It leads to pretty obvious stuff. It leads to a really long lead time before we get any development happening at all anyway. And by the time it does, you just get zombie mode. You know, my job isn't to think about implementing a solution. My job is to convert a set of requirements, detailed requirements into just typing, right? So I've got the spec is this huge unwieldy thing, and I need to do my job. What really happens? What really happens is that the team identifies local problems that, guess what, the architect didn't consider, didn't see coming, could not have seen coming, emergent stuff. And now they've got a number of options, right? The one option they don't usually have is go back and challenge. Yeah. So what do we do now? We break the rules, right? The system has to do this. Well, honestly, in order to get any work done, the system has to do something else. You know, we're going to send messages in this format. Well, I can't because that doesn't have the information I need. So I'm going to add this other thing. I'm going to make sure the person at the other end knows that. Work around the problem. There's some API problem or some performance issue that I've observed. What do I do? Well, I mean, ideally I would go in and change it, but I'm not allowed to change it because that's out of my lane. I have to stay in my lane. So I have to work around that problem. Let's imagine 10 teams are working on this thing simultaneously. 10 teams come across the same problem and aren't allowed to fix it at source. What do you get? 10 different workarounds. So now the same code is implemented slightly differently in 10 different places rather than having a single sensible solution. Or the third thing, of course, is just keep your head down. Right? Yes, it's a problem, but you know, it's above my pay grade and someone else will find it. We'll kick it down, kick the can down the road. And these are the sorts of choices that we're forcing teams to make because we've over-constrained things. So what would just enough guidance look like? Well, this is what I spent a lot of time noodling on over, I'm going to say the last 10 years, but especially the last 2 or 3 years. Is this idea of an autonomy through alignment. So I came across, as I suspect many of us did, this language of autonomy and alignment through the work at Spotify in around 10 years ago, 2012 or so. I was actually at Spotify in 2012 working with, not working on what's now referred to as the Spotify model, but working alongside that and training, coaching some lovely people there. And they were talking about, we're 300 people. We want to grow to 3,000 people. That's our trajectory, because we want to take on the likes of, you know, Apple Music and Amazon and YouTube. And what we want is at 3,000 people, we want the teams to have the same sense of autonomy that they have now at 300 people. And how do we get, you know, 3,000 people's worth of teams pointing in the same direction without kind of strangling them? And that was the homework question. And they talked about autonomy with alignment. What I've realized, and they were probably saying this, it just took me 10 years to figure it out. What I've realized is it's the other way around. You start with alignment. Okay, so alignment is the constraints, right? The framework within which. And once you have that alignment, then as long as everyone's playing by the same rules, they can go as fast as they like. So the analogy, the metaphor I always use is driving. So I drive on the left. I'm in the UK. In Vilnius, if you drive on the left, you're probably going to kill people because everyone else is driving on the right. Okay. So I need to know which side of the road we drive on. I need to know what your lights mean. I need to know what your road signs mean. I need to know who's supposed to yield at what kinds of junctions. So there's a load of, and this is all above the mechanics of driving a car. I can drive a car anywhere, right? I learn how to drive a car. That's the basic kind of agency piece, if you like, the ability to do things. Autonomy only comes when I know how we do driving around here. Once I know where to drive, what speed limits are, which side of the road, I can do what I like pretty much within, as long as it's legal. So I have a lot of freedom. And so that means that we don't need to, that the people who decide which side of the road we drive on don't have to be in all the cars. Right? We just have to know that everyone driving cars knows those rules. So this is the idea of freedom within a framework. So from a technical perspective, then, that's thinking about technology choices, okay? I don't need to micromanage every technology choice you make. What I need to think about is things that have an impact downstream. Let's go back to that data store question. So we might say some teams might be thinking about streaming data and complex event processing. Some other teams might be thinking about batch data and lots of structured data at rest, which is very much a SQL kind of problem. Yet other teams might be thinking about what's it called? Latest best guess kind of data. So for instance, if I'm getting a feed from a trading market feed, then it doesn't matter if I miss a few messages. As long as I know reasonably recently what the value of a particular stock was, it might be changing many times per second. And if I miss some of those messages, that's okay. As long as I get the next one, it's fine, right? And so you find that a lot of trading stream data is done over UDP. It's done over multicast, which is stateless, but very, very fast. Whereas other data goes over TCP, which is a bit slower, but guaranteed delivery. So, or at least connection based. So when I start thinking about these different data stores, then a whole load of products pop into my head. And if I've got a dozen teams, then I'm going to get a dozen different data stores, which again, if you look in each team, is fine, right? They're okay, except that I now have to, for each of those, I need to install it, patch it, configure it, secure it, update it, back it up, make it available, maybe distribute it. Excuse me. So suddenly now I've created a load of downstream work. And even if it's my team doing it, the you build it, you run it type of thing, even if my team is doing that downstream work, I've created that work. If we now have a dozen different data stores, that is true for every one of them. If instead, as an architecture guild, an architecture community, we say, right, we're going to have strong opinions about, if you're going to use relational data, let's use Postgres. It's fine, right? Unless you have a specific use case it's not going to work for. If you're going to have streaming data, let's use Kafka, or let's use some kind of AMQP. So what that means is this: if you choose to use these things, we already have a ton of experience, right? We've got a load of them already installed, live, running. You can go and look out. We've got teams around the place who can help you. We know how to secure them. We know their performance characteristics. We know how to operate them. If you want to go off-piste, right? If you want to go away from our paved path, you're allowed, right? You're adults, but you have to be able to defend that decision. If you say, well, I want to use SQLite. Why do you want to use SQLite? Because it's in process, super fast. I don't need the overhead of a proper grown-up database. I just need relational queries. Sounds like a pretty good solution to me. Why not use SQLite? Once several teams are using SQLite, maybe we could set up a little special interest group so you can all share your tricks. And this, again, is what communities can help with. So let's think about the technologies that have an impact downstream or that have an impact across multiple teams. And let's think about all the issues around things like administering, patching, replicating, etc. That gives us an idea where we need to be aligned, where it matters, which choices we make. And then let's think about where we're likely to get fragmentation. So let's say we're a Java shop and some teams are saying, do you know what, we'd really like to use Kotlin. Well, that's kind of an intra-team choice, right? I mean, great if we can gradually build up a hive mind about Kotlin, but at the end of the day, it's going to get deployed as jar files on a JVM in a Java runtime, which we know how to instrument, measure, scale, all of that stuff. So the shift from something like Java to Kotlin, or picking up Scala or something, is fine, right? It's a much smaller choice than saying, well, I want to go from Java to Go. Well, okay, I mean, Go then is a statically linked binary which carries its own runtime with it. We don't really know much about what it's like in production. If it fails, how do you restart it? What do you do? There's suddenly a load of downstream learning we need to do before we can be confident to say, yeah, Go's a really good back-end language or middle-tier language. So let's think about the choices that matter now and the choices that are likely to impact downstream. And those are the things that we need to think about. So, okay, so we put this thing live. Okay, we've got our digital product, our API, it's live. What happens to it? Well, this is the sort of thing that happens to it. People use things in surprising and unexpected ways. I just want to share, I really hope the audio is working here. I want to share this with you. This is one of my favorite examples. What you've got here is an API designer. Here she is. And this is her API on the right. And she has put her API live for the first time, and she's starting to see client teams using the API. And so you can see she's super stoked, she's super excited, and she's going to see how people use the API in the wild.
This is a square. Can you guess which spot that goes in?
The square.
That's right. It goes in the square.
Yes. Okay.
And how about this rectangle? That one
Also the square.
goes in there too.
Yeah.
Up next, we've got this thin rectangle.
The thin
Can you guess
rectangle.
where that
The
goes?
thin rectangle.
That's right. It goes in the square hole. And up next, a cylinder.
The circle.
I think that goes in
The circle.
the square hole. Now, we've also got this semicircle right here. Do you see a slot that would fit
The
the
semicircle.
semicircle?
The semicircle.
That's right, it's the square hole. Okay. Up next, the triangle. That's right, square hole. And up next, we have the arch.
The arch. The
You
arch.
guessed it,
The arch.
it goes in the square hole.
Probably not the UX she was expecting. Probably not. By the way, the square hole is called GraphQL. So all the others are kind of API endpoints, and we're just shoving everything through this little square-shaped hole. And it turns out that it fits. It may not entirely be what you had in mind. So this is what happens is when you put things out there, people do things with them. So if we put a product out that doesn't do enough, right, that has too little functionality, what does that look like? Well, I don't know if any of you remember when Apple started doing Apple Maps. It wasn't good. It wasn't a good look. They were competing with Google Maps. Google Maps has been running for some years and is a very mature product. Apple Maps was literally suggesting that you drive underwater to get from one place to another, which wasn't the most, I mean, it was definitely more direct. I mean, give them that, but not particularly usable. And the functionality may not be behavior, right? It may be how it works. So it may be quality, it may be buggy, it may be that it's crashy, it may be that it's not there when you need it to be there. It may be that it exposes a load of critical business information, which is not ideal, and so on, right? And accessibility is a big one because it's not just about whether something's easy to use, it's about whether it's actually legal to be online. Because accessibility now is something that, for very good reasons, is a regulated issue. And so how do people describe these products that have too little functionality? They say, it's disappointing. I think it's possibly the worst thing that someone can say about software you write. It's disappointing. Yeah, okay. Well, then let's swing the pendulum. What about when a product has too much functionality? Things that are complicated to configure or deploy or patch or upgrade or confusing, too much stuff going on. So this is kind of Build Stuff is very much a developer community, a technical conference. So I just want to share, I mean, here's a couple of examples of things that have just too much going on. So Scala is a pile of language features. The way the font I'm using meant I couldn't get the word steaming in there. But Scala is a pile of language features fighting in a sack, right? That's my own definition. It's been built as a set of language features, as a language toolkit. It's not a language; it's a toolkit of language features. And the way, you know, for the longest time, the way to get a PhD with Martin Odersky, who invented Scala, was to just add something else. You know, add some kind of higher kinded condescension to Scala, versus something like Kotlin, say. Now, both of them have the same goal, which is to take the JVM, which is an unbelievably brilliant piece of engineering, and give it a better language than Java. But then when you look at something like Kotlin, it is just joyful. I smile when I write Kotlin. I can't help smiling when I write Kotlin. PHP, wonderfully inconsistent. I mean, famously inconsistent. It's incorrect. It's bugwood compatible is the description I heard. A couple of quick examples. The Scala compiler at the moment, so this is like, let's take a time stamp at this talk, has over 25 phases. It does 25 separate things. Some of them it just does at the same time because it has to, but there's 25 different sets of things it does, right, in order to go from source code to something you can run, as opposed to the Go compiler, which compiles stuff, right? PHP, really simple example with maps. You have array key exists with underscores versus property exists. So array key exists is, does it have an array key? That you pass two parameters, the map and the key. And property exists the other way around. You pass the map and the value. The thing is, the order of map and value, or map and key, is the other way around in one of them, and I can't remember which one. And the defense is, yeah, but if we changed it now, it would break everything, wouldn't it? So we're going to have to live with it. Some functions have underscores and some don't. Some of them use names out of the standard C library, like fopen. But then you might have file underscore read underscore contents. It's completely insane. The only way to do anything useful in PHP is to just do it enough that you learn all this craziness. Now, that doesn't mean people don't get good work done in those languages, right? It just, I'd rather not be them. Okay, I don't want that cognitive load. I don't want to fight that every day of my life. Facebook famously is written in PHP, right? Or a now much more beefed up version of PHP. So yeah, it's not like you can't write significant things in these languages. It's just really hard and really unnecessarily hard. And so when a product tries to do too much stuff, what do we describe it as? Disappointing. So if it doesn't do enough, it's disappointing. If it does too much, it's disappointing. Microsoft Word versus Google Docs, right? Google Docs doesn't do much, but it does the 5% of things that I use 99% of the time. So I don't miss any of the, when's the last time you did a mail merge? Okay, I don't actually need that functionality. So what does just enough functionality look like? I love this. This is Hiram's law. A chap called Hiram Wright, who used to be a Google engineer. He made this observation about APIs. He said, basically, with a sufficient number of users of an API, it doesn't matter what you promise in the contract. Every observable behavior of your system will be depended on by somebody. Right? Anything it possibly does will be depended on by somebody. And there was a wonderful XKCD that kind of riffed on this. And it's a changelog. It says, changes in version 10.17, the CPU no longer overheats when you hold down the space bar. And someone's commented, this update broke my workflow, right? So my control key is hard to reach. So I hold spacebar and I configure Emacs to interpret a rapid temperature rise as control, right? And then they said, that's horrifying. They said, look, my setup works. Please add an option to re-enable spacebar heating. So not only are they using this wonderful bug, right? They've called it spacebar heating. They've given it a name. So everything you do is going to break someone something. So be very, very conservative about what you put in an API, because anything you put in there will get used in ways you never thought possible. So what does just enough architecture look like then? I love this quote by Randy Shaup. So Randy Shaup has an interesting CV, interesting resume. He scaled eBay. He taught Google how to cloud. He's been involved in a number of high-profile, unicorn operations. He was heading up tech at WeWork for a while, which led to some fantastic anecdotes. But Randy is the brilliant intersection of someone who's technically fantastic, really understands technology, and really understands human beings. Okay, and so an architecture meets a given set of goals within a given set of constraints. Really simple definition, but really profound. What that means is when the constraints change, your architecture is probably no longer correct. That's the first thing it means. And the second thing it means is if you don't know what that given set of goals is, you're just making stuff up, right? So the way you start with architecture is you start with the goals. What do we want this architecture to do? What do we want it to give us? And within what constraints are we operating, right? If we can answer those two questions, we're in a position to start reasoning about architecture. And then this came out as well. This is, Google talks about this. Elon Musk talks about this as well. But Google says design for 10x usage. So if you're building something for, you're anticipating 1 million users, build for 10 million. Right? Don't build for 100 million because that's probably a different architecture. But you can build for 10 million and you know that you've got plenty of overhead from your 1 million. Design for what they call the clear road. Okay, the clear road ahead may not be very far. If you've got a road that's full of hills, you can only see to the next hill, right? So only design that far, because as soon as you get to the top of that hill, you're going to get a surprise, right? The surprise might be a nice long flat road, fantastic. The surprise might be that you've just come up against a cliff edge, okay? So be aware of how far your clear road is, design for that. One of my favorite human beings, Admiral Grace Hopper, a bit of a hero of mine. So she invented the compiler. She invented computering, or invented a lot of computering. Was an admiral in the US Navy during the Second World War, and there's a wonderful interview with her on the Letterman show where he's saying, so they hired you to run their computer lab. So what, you were a computer expert at the time? And she said, no, we didn't have any experts. We were inventing this stuff. She also coined the term bug when she found an actual bug, a little physical insect inside a computer. But she says this, she said, a ship is safe in a harbor, but that's not what ships are for. When you're designing this architecture, don't fall back on things because they feel comfortable and safe. Think about what this ship is for and design for that. Design this ship to go out of a harbor and go and do stuff. And then right back to the classics, Heraclitus, a Greek writer, coined the phrase, and I'm sure it's elsewhere as well, you never cross the same river twice. So, water's continually flowing. You come back to the same place, but the river's different. It's different water, and you're different, right? So you never cross the same river twice. So even with those same constraints, future you may well come up with a different solution than present you, And present you is designing for future you. Present you is designing for future teammates. So think about them when we're thinking about what we're designing. So what should architects be thinking about then? Here are some things that I recommended to that architecture group. Remember, this is a set of people who are individual technical leaders in a sea of 10,000 human beings. And that sea is growing and changing and churning. And they are building computer systems that need to talk to each other, that need to talk to the world. So I said to them, the thing you need to be thinking about is this, is influence rather than impact. Think about the conversations you have with people rather than being an individual contributor. So how do you scale yourself? How do you become a 10x engineer? It's not by being 10 times as clever, right? It's not by typing 10 times as fast. It's by being the person who influences 10 people around you. And when you get good at that, you turn those people into influencers. And now you're indirectly influencing 100 people. And now you're a 100x engineer. You're the engineer that can influence people to influence people. And that level of alignment, that's what I'm looking for. That's next level. Remember, folks, if you're making decisions yourself, you're doing it wrong. Right? The architects, the technical leaders in my business are not the smartest people, are not the decision makers. They are the ones who can cause all of the brilliant people around them to make great choices. That's what I want. I want them, if they're making decisions themselves, that's a local optimization and it's a bottleneck. And the one thing I don't want is bottlenecks. So then what? Provide the alignment that enables autonomy. Provide policy, but don't do policing, right? We assume people are grown-ups, and what they want is the constraints within which, the framework within which they can make good choices. Absent those choices, they'll guess, right? And as I said, each of those guesses individually will be fine. When you pan back and look across all of those guesses, it's going to be a mess. And so what do we want? We want kind of we want Goldilocks leadership, right? Not too hot, not too cold, just right. Okay. So we want just enough guidance, just enough steer that they can make good choices and they can make choices consistent with their peers. We want just enough functionality. We want these systems to do what they're supposed to do, nothing less, but we don't need any more. Any more than that isn't being clever. Any more than that is being overwhelming. Okay. Is it available enough? Is it resilient enough? Is it robust enough? Is it observable enough? If it is, you're done. And the reason I say that is this: of course you can dial everything up to 11, but that's opportunity cost, right? All the time you're doing that, you're not on the next thing. Okay. And someone else is, and that's how they eat your lunch. And then that means that we end up with just enough architecture, just enough technical constraints, technical guidance, that we can bring our technical folks on a journey with us to make good choices. That is what technical leadership looks like. That's kind of all I wanted to talk about. So we've got a few minutes, I think. As I said, I'm not sure how questions get to me through this little Zoom bubble that I'm in. I'm going to hope that one of the wonderful people at Build Stuff is going to be able to funnel something through.
Any hands? I got one in the back. Sorry, Dan, I know you probably can't see us, but we're walking down the room. Please.
No worries.
Thanks, Dan, for the talk. So I'm not sure if it applies to your organization, but some organizations have engineering managers and let's say principal developers or even architects. How do you see them kind of cross? What should engineering manager do from that list that you shared, just enough guidance and things like that? And what should architect do? How should they cooperate?
I love this question. I think it's brilliant. And again, so this is work. This is exactly what I've been working on for the last bunch of years. So I'm specifically today looking at technical alignment. How do we make good technical choices? Alongside of that, we've got ways of working alignment. So I want people working in similar ways. That doesn't mean we've got a bunch of identikit teams. I'll give you an example. I was working at a large retailer in the UK. Around 200 people working on their all of their digital platforms, so website, mobile, all of that, several £billion worth of revenue going through it each year. And we had, I think at one point we had about 20-something teams between kind of 5 and 10 people in each team. And we said to them, look, we're not going to tell you how to work. Right? Necessarily you work in different ways. The people on, say, iOS mobile team, their path to live is submitting things to an app store, right? The web team can just do multiple intraday drops. So there's no point imposing ways of working. What we said is this: on a 2-week cadence, every 2 weeks, we want you to be able to tell us how much work is going through your system, how long does each item take, what have you got in flight at the moment. So in other words, lead time, work in process, and throughput. As long as you can do that, do what you like. And so each of the teams worked in very different ways. Some of them worked in similar ways. So the ways of working alignment meant that we could stand back and squint across a 200-person program and make sense of it. Likewise, product alignment, right? Are we building the right thing? Or are we all building similar things? Are we building in the same direction? And then we look at focus alignment. What's up next, which is where the kind of space for OKRs. So if I'm looking at engineering managers, principal devs, and architects, which is, I'll jump on your terms. My architects are essentially, if I'm looking at enterprise architects, my senior architects, their role, if you like, is technical policy, right? Is technical alignment. The principal devs, I imagine they are the technical leads on significant programs of work. So their job is to help map that architectural vision, that technical alignment into their world. And so they're going to work, they're almost like an interface. They're working with the technical leads, so with the architects, to agree what good looks like across the organization, and also how you project that into their world. And then the engineering managers are then, that's more like the operational side. So this is about ways of working, about keeping things consistent, where I need those operational metrics, like my flow metrics. They're helping out with that. And they're also helping the various folks who are doing the coding, doing the kind of the technical day job, to implement the ideas of and the guidance of the principal devs. So I hope that separation makes sense.
Thumbs up. Thumbs up. Do we have any more questions,
Fantastic.
Dan? Scanning around the room. It looks like we have no more questions. Can we get a round of applause for Dan North?
Thank you very much.